Hi students, now we will discuss the fifth MCQ of Unit 3. The question is on display. A thin insulated wire, it forms a plain spiral coil. Number of turns is 100 totally, carrying a current of 8 milliampere. The inner and outer radii are given. What is the magnetic induction at the center of the spiral? Okay, immediately we can think of using the formula B is equal to mu naught Ni divided by 2R. So this is the formula to find out the magnetic induction in the center of a circular coil having N turns. But the only difference between using this formula for N turns and the current context is that in the case of the formula being straight away used as mu naught Ni by 2R, all the number of turns, all the N number of turns are assumed to be at the same distance from the center at which we are finding the magnetic induction. But the current context, it's a spiral coil, and it's of course a tightly wound spiral. It's given by the word tight turns, so it should look like this. So immediately we can understand that the distance or the radius of the first uh, turn, which has a radius A, inner radius A, has a very small radius comparatively, and the radius keeps on changing. As the number of turns keeps on increasing, the radius also changes. So you can understand that this particular formula cannot be uh, readily applied. That means I cannot write the value for mu naught and n as 100 and then say substitute the values for the other symbols. So this kind of a problem is not straightforward. These kinds of problems are tackled, and in fact, the methods to tackle this kind of problems are given in a classic Russian book, Mir publishes book by the name General Methods of Solving Physics Problems. This is a great book, beautifully written by a Russian author by the name B.S. Belikov, in which the author talks about a method called DI method to solve this kind of a situation. The DI method is nothing but it's a two-step process. The first step is to write the differential form of the given relation, and the second in which you have to integrate that form within the limits and then get the answer. Okay, let us come to our, of course, you can read this from the book and then say understand the beauty of this method. I'm going to adopt that method over here and then solve this one. Right. Okay, let us consider the scenario here. Okay, let us take the center point over here, and then at a particular distance or radius r over here. So from the center till this point, let us assume that the radius is r. And let us also consider that the number of turns up to that is, let us say, n. So I'm going to consider that as n. And if you can take a very small region, in the, it's, let us assume that as dr. It's a very small region, dr. In that region, and of course, the number of turns is increasing to over here the number of terms gets increased to n plus dn. So we will now write the values for both the places. In the inner portion where the radiuses are, the formula remains the same. In the outer portion, we will take the value as b dash, which will be then equal to mu naught I into n plus dn divided by 2r. And of course, I can also write the b as mu naught I n divided by 2r. So here I am assuming that in that very small distance of dr, r is a constant. Okay. Now subtracting these two, the incremental value, the very small change in the magnetic induction will be dB, which is nothing but b dash minus b. This will then be equal to, if you can subtract these two, you will find very easily b dash minus b will yield mu naught I divided by 2r and then dn. So this will be the expression for dB. Okay. Now, so this is the first step in which we have written the differential form of the uh, relation that we have to use here. Remember, there are two variables in this equation. N is a variable as well as R is a variable. But I am now writing this expression in the differential form. Even in this differential form, you will find out that this dn is the differential element and R is also a variable. Let us try to rewrite this particular equation in a little more uh, understandable or little more easier form to calculate. So what I will do is I will consider the entire spiral coil, and we know that the total number of turns is n. So for the total number of turns, what is the actual distance or actual width of the coil? You can say that the outer radius is b and the inner radius is a. Therefore, in a distance of b minus a, in a distance of b minus a, I can call b minus a meters. In that distance, the number of turns is total, which is n. So we will try to find out the number of turns in unit distance. So for 1 meter, the number of turns will then be n by b minus a. Are you following this? Okay. Now for unit distance, we have found out the number of turns. So this is the number of turns for unit distance. Then we can find out for any distance. Okay. The distance between the points that we have considered here is a very small distance dr. So in that distance of dr, what will be the number of turns? That is what we have to find out, and that is what we have written in the equation 1 as dn. Therefore dn is nothing but n by b minus a into dr. So this is what I will substitute in equation 1 now. So therefore dB is equal to mu naught I divided by 2r n by b minus a into dr. Now let us write this expression with all the constants taken together on one side, which is mu naught I. The total number of turns is not going to change, divided by 2 into b minus a, and then the variables are only now these two. Now this is our expression which we can easily or readily integrate. So the second step is the integration process. I have to do the integration. So we will get b on the left hand side. Integration of dB will be b, which is equal to, let us take all the constants out and do the integration only for the variables between dr by r. The limits are obviously the inner radius between A and the outer radius B. You must know that this form of integration will give you natural log or ln or log base E of R between the limits A and B, which will therefore give you log B minus A, sorry, log B minus log A. This of course can also be written as log of B by A between the limits E, which we will substitute and then try to find out. B is therefore equal to mu naught's value is 4 pi into 10 power minus 7. The current given here is 8 milliampere. So 8 into 10 power minus 3, milli means 10 power minus 3. Number of turns is 100, so I will put it as 10 power 2 divided by 2 into the outer radius is 100 mm, inner radius is 50 mm. If you subtract the 2, you will get 50 mm, which of course can be written as 50 into 10 power minus 3 into log 100 mm B divided by 50 mm A. The base is E. This is 2. 10 power minus 3 can be cancelled. 2 into 50 is 100, which will be cancelled by the 10 power 2. Therefore, the net value will be 32 into 3.14 into 10 to the power of minus 7. Log 2 base E can be written as 2.303 times log 2 to the base 10, which of course is 0.3010. We can find out these values and then check them out. So the values that we have to multiply are 32 into 3.14, 3.14 into 2.303 into 0.3010. So the answer is 69.65, approximately 70. We will write both. 69.65 into 10 power minus 7 Tesla, or approximately 70 into 10 power minus 1 minus 7 Tesla, which can of course be written as, if you can reduce the or bring the decimal point to over here, you are reducing the decimal place by 1, so it's 7 into, you have to increase the power by 1, so 10 power minus 6 Tesla, which can also be written as 7 micro Tesla. You can check the answers available here. You can readily find the answer to be 7 micro Tesla here. So this is how we solve the question number 5.